So we're here today with Jim Schofield to talk about his systems approach to science, to holistic science. And we're going to talk about it via the work of Denis Noble. Denis Noble is a scientist, a biologist, who thinks that we need to move away from a reductionist view of biology. So that's already placing us in a sort of holistic way of looking at things. And he even talks about systems himself. You know, he talks about the idea of systems biology. So that's what we're going to have a look at. So maybe I should start by reading a quote and seeing what we think about it. Maybe that's a way to kick things off.
Yep, I'd say so.
He states that the book is about his idea of systems biology, and he also talks about a systems level approach, which is very similar language to what we've used, the word system being important, the word level being really important, and the word approach as well. And he talks a little bit about how he got to this point. He says that he started his research career in physiology as what he called a full card-carrying reductionist. And he says, I knew how successful reductionist science is done. I've done much of it myself in my own field, and I still use its methods quantitatively in my own current research on simulating organs of the body. And that's how, during the last decade or so, I've come to see the need to redress that balance. If we all keep our noses down to the low-level grindstone, no one will ever get to see the bigger picture or realise what's needed if we are to fill it in. It says successful integration at the systems level must be built on successful reduction too, but reduction alone is far from sufficient. So I wondered whether you agreed with that. Do we still need to do some reductionist science, or is that the problem?
Oh yeah, we still do. But the trouble with leaving out systems stuff is that we leave out important things that really do happen, but nobody looks at them.
Yeah.
That's the difficulty.
Yeah, certainly. So, I mean, it's I guess the difficult way to square the circle there is that you might get exceptionally different pictures, whether you're looking at something from the top down, which you might do if you're trying to look at something holistically, or the bottom up, that you might get a completely different picture of the same phenomenon.
I think you do.
Yeah.
My experience is that sometimes what you get from the bottom is like having only part of the truth. And therefore, when you look at it from the top and you get things happening that can't possibly be arrived at by the other method, they differ. You're getting different answers.
Yeah, I mean, and he kind of speaks to this as well. So there's a chapter where the whole book is based around a metaphor. So it's called "The Music of Life" by Denis Noble, and each chapter is based on a musical metaphor. So this one is talking about how we can look at life as almost like an orchestra. And the chapter's called "The Orchestra and Organs and Systems of the Body." So that's the kind of general theme. But in this, he talks about different approaches. He talks about a bottom-up approach and a top-down approach, and he says neither work. He says that the top-down approach has been successful as a tool in physiology for many years. Taking an understanding of circulation, for example. It's kind of looking at a whole body way of looking at things. And he says that using the top-down approach, they've kind of drilled down through the levels until they reach the bottom. But then in order to understand how they've got there, they end up having to use a de facto bottom-up approach to try and work out how they've got there. So it's almost like they can't escape from the problem of the bottom-up approach, because they're still struggling or failing to relate the different levels of reality that they're dealing with.
Well, I think that's exactly correct. Because what I'm finding is that you can't make analysis of the top-down approach in terms of a bottom-up approach. You can't do it. Because things are happening there which you don't even know are happening from a bottom-up approach. So there's no way you can explain the thing at the top. You've got to come in it from another angle entirely to understand the top-down approach. Really, quite a different angle. Not in terms of mechanisms that are underneath, but in terms of environment, in terms of, contingency, all sorts of things that aren't included in your bottom-up approach. Remember this, in a bottom-up approach, you keep things steady. You tend to control your environment so that it behaves as you expect it to.
I think there's another thing colouring the way he's looking at this as well, and that's that he's talking about the body.
The body,
and the body is already a closed system. So there's a semi-closed system. You've got less outside factors than you would, for example, if you were looking at a whole ecosystem or something where external things can come in and out all the time. I think, and a lot of sort of cycles and things in the body as well, they repeat, they're stable. A body is a relatively stable structure, isn't it?
I think that's exactly right, because what I'm coming across in my work has nothing to do with life as such, what I'm doing. But you do find that you get things happening from a top-down approach, which are nothing at all to do with anything from the bottom. Nothing at all. I mean, the most important one that I found was, that's it. It's when something ceases and you don't know why. Now, the way they normally do it is they go to a bottom-up approach and try and find reasons why that thing would cease. That was going on merrily for a long time, and then suddenly it stops. And you cannot find the answer from a bottom-up approach. What you've got to do is you've got to see how things work together. Multiple things work together. Because occasionally it's in that working together that a failure occurs. It doesn't work together anymore as it used to.
Yeah. I mean, his solution, again, I think is maybe coloured by the fact that he's talking about physiology and cells and things. But his proposal is that we don't use top-down or bottom-up, but we use what he calls middle-out. And he's come to this idea from what we could consider to be a reductionist approach anyway, even though he's anti-reductionist. As he says, a lot of his approaches are still reductionist. So he models organs. I don't know if I've already told you this. And he was the first person to construct a virtual heart. So he's obviously got a hand in simulation, which is, again, a sort of reductionist approach to science, isn't it? But yeah, in sort of developing this idea of a virtual heart, he came up with this idea of looking at things middle out. I don't know if I can paraphrase him sufficiently here to sort of work out more what he's talking about. If I can say
something here that might be relevant.
Yeah.
I work with Jagan Gomatam on modelling the heart. And one of the things that he did was he used a model from electronics, which he found to be similar to the patterns of the beating of the heart.
So an analogue, basically.
Yeah, an analogue thing. So what had to happen was we had to find out where it was happening. The electronics was happening in one particular range of possibilities, but the heart was happening in quite a different range of possibilities, but had the same form.
Yeah.
Now that's interesting, because how the hell do you connect the two?
Yeah, certainly. I'm starting to wonder whether there's actually a closer connection between your research and Noble's than we think, because Noble might well have influenced Gomatam.
I think.
Looking at the dates, yeah, he was doing this in the.
Gomatam was very good, by the way.
Yeah, I'm wondering whether with the ghost of Noble's been haunting your thinking for years anyway. But yeah, I think this middle out approach, I'm not sure whether I fully understand it. I mean, it's definitely to do with understanding the organisation of systems into levels. So I'll read another quote out and see what we think about that. He says, biological function happens at different levels. We can gather quantitative data at any level, but once we have enough of it to feed into a simulation, we can start a systems analysis at that level. All levels can be the starting point for a causal chain, so any of them can be the starting point for a successful simulation. In networks of interactions at many levels, there is in fact no alternative. Analysis must start somewhere, but in fact it doesn't really matter where. So I don't know what you think of that. So he's almost saying it doesn't matter where you start, you've got to start, so we almost pick a level to get data from, and that's your starting point. But
well, I mean, I haven't actually cracked it yet in my area, I must admit. But what I'm finding is I have to start at the top and study what's special about those situations up there that doesn't occur in any way lower down. It's particular to that level, right?
Yep.
So you're finding a cause, but you're finding it up there. You're not finding something underneath that makes it happen. It only happens at the top level. Only. Now that, I think, is significant.
Yeah, I mean, I think what the other thing he seems to be extolling the virtues of is trying to understand lower levels in terms of higher ones. So he says, as we reach down towards lower levels, we can rely on our higher level analysis to identify just those features of the lower level mechanisms that are relevant. I think that's probably what science is always doing anyway, isn't it? I mean, you're choosing to ignore stuff, and I think that's the problem, isn't it?
Yes.
that selection, which Noble is saying is important, and maybe it is in order to do certain kinds of science, but you are going to miss stuff if you're that selective and say we're only going to pick what's relevant.
Well, that's certainly what I've found. I've always been taught to do the bottom-up stuff. I was a physicist, right?
Yeah.
But there was lots of things I just couldn't answer. It was impossible by the methods that I'd been taught for years, all my life. And it was only when I turned things around and starting at the top and seeing what happened up there that didn't happen anywhere else. So what Noble says about levels is right.
Yeah.
But there's a certain independence of levels. Now, it's not real independence, because what I'm saying is things happen at the top level that affect things below. But you can't relate them the other way. You can't, in fact, explain things happening at the top level solely in terms of things happening below. It is pertaining only to the level, even though it has effects downwards as well.
Yeah, and I think...
that people don't like that. That gets rejected.
Messy. It's too messy.
Yeah.
I mean, I think that's the thing as well, is like one of the things that we haven't seen in this or in any scientific analysis is the role of contradiction. You know, different levels can seem to be doing oppositional things or things that don't make sense, or you get paradoxes, and that's because, again, there's that systematic rationality that's taking over and saying, well, something, you know, A can't equals B, A has to equal A.
I'm convinced that contradiction is important.
Yeah.
And I don't think contradiction is what they usually say it is. They usually say it's a mistake, you haven't got all the information. No, they do push in different directions.
But also, I think that, you know, the idea of you not having enough information, they've chosen to ignore loads of stuff.
Yes.
So they've never have enough information anyway. I mean, this is one of the things that he highlights here as well. He's saying that this selective process is vital, the one that we're saying we shouldn't. And he's saying, because it allows us to highlight what's important in what would otherwise be an overwhelming mass of data. It greatly reduces the amount of information that we must carry over from one level of analysis to the other. So he's basically saying it's impossible, that we have to be selective, otherwise the job becomes impossible. I mean, I guess this is the major stumbling block for holist science, isn't it? You have to at some point put a limit somewhere and say we can't look at everything.
But there's a direction that you shouldn't ignore. It's perfectly true that you will simplify, or you will locate what you're doing at a certain level and find everything within that level. That's okay. But you've not got to think that will contain everything that you need, because there'll be something happening at another level which has no precursors in the lower level. You've got this two-way process that isn't balanced. The thing at the top can affect the thing at the bottom, but mechanisms at the bottom don't necessarily always affect the top. It's not balanced, and that's what people don't like. And I think that the reason that you get stabilities occurring is that you get opposites that balance. Stability, I think, comes from opposites that balance.
I mean, are there balancing opposites? There must be in a heartbeat. Because I mean that's not there. There's an example of a stable system that can go into crisis.
Yes.
And it can be a stable system that repeats for 1 billion beats or whatever before it goes into crisis. And this is one of the ones that he talks about as well, because obviously this is another area where you've both done similar research in modelling the heart and cardiac arrests. And this is an example he gives as well. He says we can do this because we start with the systems level phenomenon, the cardiac arrest. So it was him trying to work out what was happening by starting at that kind of macro view and looking at the cardio arrest holistically, and saying that's what we have to try and explain. And he says the imperative guides our investigations into what's going on at the lower levels too. But if we restricted ourselves to what he calls the gene's eye view, we would never achieve comparable results. We could deduce that there is an electrical charge change in the protein that the genes code for, but we could never determine whether that would be sufficient to cause a fatal heart arrest. That depends on higher level events.
I'm sure that's true. Sure. It's impossible in the work that I did with Jagan Gomatan to get the heart attacks and the fibrillations that we got from the bottom up. You could only get it by having a kind of rhythmic system that pushed in one direction and then in another. And there was a kind of balance between them. And that's like the beating of the heart, right? It's only when those opposites, instead of being stable and always carrying on, one got too big and the whole thing stopped. But that was happening at the top level, not below.
Yeah, so I mean, that's the interesting thing, I guess, that Noble's trying to address and is missed in most science, is that they keep drilling down to try and find fundamental things on which everything else is built in their standard reductionist way. They miss...
It's like Lego.
Yeah, but I mean, you could say that the Lego exists, but studying Lego bricks doesn't tell you what you can build out of them.
I think using an analogue of Lego is a good one, because you can explain a great deal in terms of small units making bigger ones. You can, but there are certain things that will not be explicable in those terms at all.
No, and one of those is why the building collapsed.
That's exactly right.
You know, I mean, analysis of bricks is not going to tell you why the house fell down.
That's right.
Particularly as often.
I think
the
that's
bricks,
a very good example, the one you just said.
Particularly as the bricks generally remain intact.
That's right.
You know,
there's all the bricks, and there's nothing wrong with the bricks. Why did it fall down? And it was nothing to do with the lower level.
Yeah, and I think, you know, even though there are definitely some differences and points of disagreement between our approach to systems and Denis Noble's, I think we've got a similar. There's common ground there in this sense that
I think it's very important to make relationships between something that I'm doing and life, which is what he's doing. I think it's a very, very sound example.
Well,
because there's lots of cases in living things where you have these levels piled on.
I guess the extension to that, when we're talking about addressing all of science and even physics holistically, is that this doesn't stop with life, that even the laws of physics may have features like this, that in reducing everything down to the quantum level and trying to understand the cosmos in that way misses things in exactly the same way that we miss heart attacks by looking at genes.
I think that's true. I think it's true.
And maybe a lot of the problems in physics are because really no top-down systems analysis has been attempted at all.
Well, in my area, that is true. None at all. In the stuff that I'm studying now, there's no top-down. There really isn't. None at all. I'm having to invent it. The way I'm doing it is by trying to isolate at top levels multiple things that are happening only at the top level, and the way they balance and affect one another. Because if you've got macro things at the top level that can get out of balance, you might not be able to explain that at all in terms of small bits down here. It is a feature of the level where the balance is happening. It's to do with balance at a given high level. How can you possibly explain that in terms of a much, much lower level down with the things that happen there? Because that's not what it is.
Yeah, and I guess
the balance doesn't occur at the lower level, it only occurs at the high level.
I guess that when you can bring emergence type theories into this idea of systems and top-down effects is when you get a situation where a house collapses so catastrophically that the bricks are affected, and that's when we might be able to get a situation where top-down system effects start to rewrite the supposed laws of nature, and we start to get lower levels being affected by problems, issues, imbalances higher up. And I think that's when it would start to become a really holistic analysis, because you're not
in a supernova.
Yeah.
That's a top down.
Yeah, I mean that's an interesting one, because I'm sure there are physicists that would say that it could be something that's starting at the bottom. You know, the fusion level runs out. So you'll have to excuse my lack of knowledge of physics here, but the fusion reaction runs out of fuel.
Supernovas are so rare that billions of years elapse before it happens. Billions of years. Now, how the hell are you going to explain that event in terms of little things that have been happening for billions of years?
I guess as well, like when the way cosmology is done and physics is done at the moment, and the way they're combined, again, it's done in this reductionist point of view, not just in terms of looking at individual reactions or individual quantum particles, but also just in terms of individual stars are being looked at individually as if they're not in any way connected to anything else. And that's the problem, isn't it? There's no acknowledgement of the interconnectedness of things, ever. And you might think, okay, stars are fairly isolated anyway, with a vacuum in between them. But if you start to look at the more cutting edge stuff that we see from plasma physics, there is increasing evidence that things like stars may be connected.
Yeah. Well, they actually think, and there's good evidence for stars being in plasma streams. You're having a plasma stream and strung along it like beads are the stars. There are people, scientists, who insist that that does happen.
And it's
I'll explain that.
It's no more way out than Einstein's relativity that saw stars strung together by an invisible space-time continuum. Anyway, I think the thing is we're not really sure what's connecting things. We don't have enough information, do we?
We can't.
But to assume
we're limited, really.
To just assume that because we don't know about it, they must be isolated, and we can treat them as if they're in isolation, is always a mistake, isn't it?
Yes, I'd say so. From what's happening with the as you say, the plasma physicists, they say everything's connected at the cosmic level.
I guess that's bringing us nicely onto Electric Universe, isn't it? The problem, I guess, the pitfall of the systems approach, the top-down approach, and the idea of holistic science is because it's not necessarily grounded in data, it opens the doorway to a certain amount of quackery, doesn't it?
Always, yeah.
And that, how you deal with that, you've been stuck between the devil and the deep blue sea, aren't you? The devil being literally the detail, and the detail merchants being completely data-driven and missing loads of stuff because of that. And the deep blue sea being the fact that once it's completely open, you can have people saying anything. And you do seem to get that.
You do get that, yeah, that's true.
And so it's almost that, I guess that's the need then for a rigorous holistic method, isn't it? Something that
well, that's what's missing, in my opinion. There isn't a holistic method.
No.
Ever since the dichotomy occurred, which occurred in the 5th century BC, between, on the one side, the Greeks, and on the other side, Buddha. Buddha was a holist and said everything's connected. And the Greeks did the opposite and analysed things down. And that was the split. It's a long time ago, that. 2,500 years ago.
Yeah, and we're still grappling with the same problem.
It's no good you saying this side's wrong and that side's right, because when you look at what the Buddhists say, they found that they couldn't go very far because they had too much to juggle with. Yeah. Too many variables.
Which is similar to what Noble says.
Yeah.
So it's a problem we haven't solved yet, for sure. Yeah, obviously we've only briefly touched on The Music of Life by Denis Noble here. We've just sort of cherry-picked a few quotes, really, but I do think that this is probably an interesting thing for us to be doing, because if we're trying to find examples of where a rigorous holistic approach could be conceptualized, it's got to be in where people are doing science roughly in this area. So even if they're not managing quite yet, or it's still very reductionist, they're at least trying to think outside of the confines of reductionist science, and they're managing to do something. They're managing to build a model of the heart that works and can predict heart attacks or whatever. If they're doing things like that, they're getting something a little bit right, aren't they? So maybe that's where we can start to look for how we can arrive at a more general methodology that you could apply to other disciplines as well as biology. Do you think it's worth doing that kind of research to see what people like Noble are doing?
I'm certain. It was clear to me that I was beginning to see this organisation of levels, but instead of it being just a bottom-up organisation where everything above depended on what was below, you also had it going in the opposite direction, that something at a high level could affect things below. And that two-way causality is not grasped at all, as far as I can see.
And I'm sure that's where you're going to get all sorts of interesting oppositions and
I'm
contradictions.
certain that happens. From my experience, I'm certain that happens.
Because it's not a unified whole. I think that's where you're going to get contradictions. If you can get both top-down and bottom-up effects, they can contradict each other.
That's right. And the other thing that I thought about, but now I'm better on it, is this idea of opposites. I mean, Zeno and then Hegel and then Marx all realised that diametric opposites were important in logic and undermined what the Greeks had done. They saw that. And I've now seen it to be very, very fundamental to systems generally. That it really is a contradictory model that seems to be built up from the bottom, but also is built down from the top. How would you explain that in a consistent model?
Yeah, and I guess Noble tries to do it with his third way, which is this sort of middle out way.
I don't think that's the middle out.
No,
I don't think it's that. Do you know what else fits into this beautifully? The idea of emergence. Because what emergence says is that you've got a system building up from the bottom. Okay? So you think you can make all the new levels in terms of what happens below. But the situation always occurs that at some point you get something happening at the top that then makes the whole thing collapse. Now, how the hell do you to deal with that?
Yeah, I think the idea of levels is interesting. I'd like to see how Noble defines a level, because I don't think it's that easy. It feels like it could easily be an abstraction. You say everything at this scale is on a certain level, or everything that operates in this way is at a certain level. But I have a feeling that those clearly defined ideas of levels are probably a human construct as well, aren't they? And they're a way of us trying to analyse something that may be more shades of grey than that.
Well, I don't know. The one thing that I'm becoming convinced of is that independence has a role. That you do have a measure of independence. In fact, it's only in crises that your independence is lost.
Perhaps that's what gives you the model of a level, in that you can analyse a certain situation and say if certain things at a certain scale have a measure of independence, only then you call that a separate level of reality.
Yeah, that's a possibility.
If there's no detectable independence, then it's not actually a separate level. It's part of either the level above or the level below.
And the interesting other side to that is that a level may be consistent, or seem to be so, because what's causing it to fail is not in that level; it's in another level.
Mm. Yeah, and that's one of the other things we were talking about, wasn't it? Was this idea that levels are both independent and dependent at the same time, which is another classic kind of Hegelian style contradiction, isn't it?
And yet I'm pretty sure it's true. Mm. I'm pretty sure that our easy way of handling things is a simplification, and that reality is more complicated and has these relations between them. You can do certain things very easily by defining levels and assuming bottom up within the level. But then when you get crises occurring, my God, the whole thing can go. You know, one of the things that we should always think of here is a revolution. Mm. Most of the time, you've got balances that are being lost and then regained. You know, it's not forever. And therefore, that keeps the situation more or less stable. But what you get in a revolution is you get almost a cataclysm of failed things. And it's like
a chain reaction.
like a chain reaction, of course. That's a good example. And why is it that you can get a chain reaction? That's a good question. You're not going to be able to explain that in terms of bottom up, because all the levels are involved. Why is it that when you've got a whole big overall system of levels that seem to be independent, that the whole lot can come crashing down? A good question.
Yeah, and I think that based on the oversimplifying ways that science has historically managed to get a grasp on things, it can't tell us the answer to that. And I think looking at Noble, even though he's singing from a similar hymn sheet to us, he's still saying that we have to try and simplify things to some degree, because the infinite amount of levels of reality and things that are going on there is just too complicated for us to understand. And so science historically has gone in and tried to reduce, tried to simplify. It thinks it's finding essences. But how do we move beyond that approach? Because that's been the approach for hundreds of years now.
And let's face it, it always in the end fails. This is the point about it. It may work for now, or even for quite a long while, but at some point or other, it doesn't. It fails. So it's a time-based thing as well. You could say, if we take it over a very short period of time, this is stable, and this causes that, and this causes that, and that causes the other. But if you extend your time scale, that ceases to be a full description.
It's interesting because I think it reminds me of Henri Bergson, the philosopher, as well, because he said that rationality is the thing that constantly limits us because of the way it works. But intrinsically, the way rationality works is to break things down into components, to simplify, to find essences. And he says that's only one way the human brain works. There's other ways that the human brain works that we don't feel like we have direct access to. And he was a big believer in the importance of intuition for understanding complex things, because he says there's a way of thinking, there's a part of the brain that doesn't do that. It has built into it almost a way of holistically grasping things, and we don't understand it. We don't understand our own brains, because that's what artists tap into. You know, an artist is not breaking things down into components. An artist has an intuitive feeling about reality and articulates it in some way which you can't analyze, and yet it still has truth in it.
Yes, it does.
So to analyze it is to kill it. It's to kill the very thing that it's managed to capture. So maybe there's a role for intuition in science.
And I'm still feeling that the intuition is to do with balances. It's a judgment of things going out of balance. That intuition you're talking about. See, when the balance is there, you've got a stable situation you can predict. But the brain can perhaps notice when things seem to be out of kilter, seem to be moving towards imbalance.